This video is brought to you by Sporlan, quality, integrity, and tradition. We've got a call that an air conditioner, this is their kitchen AC, is not working right. And let me give you some context. We actually had a call over this past weekend. It is Tuesday now, but we were only able to get it running. I got to try to figure out what's going on with it, okay? So had a service technician come out here. He found that the unit had 2 blown fuses. He tested for everything to ground, couldn't find any shorts to ground or anything. Put new fuses in it, started it up, and it's been running ever since. But we got to try to figure out why these fuses went bad, okay? So I fully expected to come back out today and have it be down, but that's not the case. Came back out and it is operating. It is running. As best as I can tell, both stages are running, okay? I opened up this guy just to look, and I'm already seeing that there's a very distinct discoloration to the right 2 fuses. Something is funky there. All right, I have not opened it up to look at the compressors yet or anything, but I'm gonna get my thermal imaging camera out and let's look at those fuses because that discoloration is kind of odd to me. Now look at this. It's amazing what these thermal imaging cameras can show you. Line 2 and line 3 clearly have some sort of overheating going on. We should have clean, consistent temperatures across that disconnect switch. I'd expect a little discrepancy if you have more of single phase load on something in there, but yeah, we need to dig into this thing, definitely. I think we have a bad connection in the top of this disconnect. I'm gonna attempt to tighten that lug in the top, but I think that the blades are not making good contact and they're causing some high temperature issues, which might be leading to fuses, overheating, and potentially breaker issues. So let's look into that disconnect a little bit more. All right, so line 1 is running currently right at 32 amps. That's line 1. Line 2 is at 31 amps right there. And line 3 is at 31 amps. So nothing excessive. Let's go ahead and test some voltage here. And see if we have any kind of a voltage discrepancy. Another thing is right up here in the top, that wire's burnt. So it's overheating big time right there. Big time, something's going on. I have an insulated screwdriver right here, and we're just gonna give these a quick torque to see. I mean, they're tight. Yeah, wires are tight, or lugs are tight. There's nothing going on there. We're making contact with the wire. I honestly just think we have a bad disconnect switch where these knives right here are making connection with the top. Now again, I don't know that anything else is going on, but we're running 30 to 32 amps. Let's come over here to the nameplate. What is the unit's minimum circuit ampacity is 38 amps. The RLA of each compressor is 12 amps. Indoor fan motor is 7.5 amps. I mean, it doesn't seem minimum disconnect fuses are 40 amps. Maximum fuses are 45 amps. Someone has the wrong fuses in there, but that's a whole nother thing. Yeah, I'm looking at a disconnect switch failure on this one is what I'm looking at. We're gonna have to do something about that because yeah, it's just not making good contact in here. So let's go ahead and get this disconnect switch flipped or switched out. When we powered it down, you can clearly see that there's been a lot of arcing and there's like some buildup going on those 2 guys where it's just not making a great connection. So yeah, we got to swap that disconnect out. Now, I know there's gonna be a lot of people, why don't I sand it down? Because it's a disconnect that's failing. This is an older disconnect. We're not gonna just try to, you know, clean it up. I'm gonna just go ahead and swap it out. So I've got a new disconnect switch here. I brought one with me actually because I was already suspect of the disconnect because the technician that was here told me that the fuses were discolored and these things do have a high failure rate. Now, I want to talk about why I'm not just going to sand up these points and put dielectric grease on them. For me, once it's already damaged like this, I'm not a huge fan of doing that. You know, you can attempt to try to repair it by sanding up. This is just my personal preference. I get it. I'm not judging anybody for sanding these and putting dielectric grease on them. It's all good, whatever you want to do, right? For me, we have a lot of sand in this area and stuff, and I'm not a, you know, once that sand starts to get in those points, it creates a problem. And I'd just rather put a new disconnect switch on and be done with it and know that there's no problem with that. That, again, my personal preference. I understand if that's not the way you want to do it, you know? So, all right, we're gonna get this guy swapped out real quick. I personally think it was a little bit easier. I just did a gut swap. So I pulled all the components out, the handle and everything, and just swapped them out. It was just 4 screws. Put a new cover on there, left the same housing because there's nothing wrong with the housing. I don't got to get in here and start undoing conduit and stuff. To each their own, you know. I mean, it may or may not have saved me time. I don't know. I just went on a kick right now. So the next thing I'm going to do, I did move the colors around, but I kept the phase rotation color to color the same, okay? So now what I'm going to do is we're going to torque these guys down, but first I'm going to smash the wire, okay? So tighten, carefully, loosen, tighten, keep doing that on each one. So tighten, loosen, and then each time it'll go tighter and tighter because we're smashing down the wire, okay? Then we're gonna make sure it's loose, and then we'll put the torque driver on there. And I'm gonna do that for every one. Be careful because you can break these screws. All right, so now we're smashing down the wire. I know if I use ferrules, we wouldn't have to do that, but I don't have them, okay? So I'm gonna do that, and then we'll get the torque driver out. On the panel right here, it tells you for anywhere from 12 to number 2, tighten from 45 to 50 inch-pounds. So got it set up for about 48. I'm using the WeHa torque driver, and again, you want to be careful because these screws will break, so you want to get them centered. Yeah, I'm gonna have to get 2 hands on it because that's pretty tight, and like I said, these little aluminum screws, they will break right off. Let's try and see if I can get this one or not. Yeah, see, it starts to break the screw. So I got to get in there with 2 hands so I can press firmly, make sure I get these torqued down properly. And in the spirit of being proper, they give you a little green screw to put in there to help you indicate that this is a ground terminal. I mean, the green wires coming into it kind of indicates it too, but I tightened it in. So all of these tightened down are at 48 inch-pounds. I think that's how you say it. It's a lot tighter than I'd expect it to be. That's pretty darn tight. We actuate, closes, we're good to go. This guy's in. I'll close this lid. I'll put some spare fuses in there. 45 amp fuses, because that's the max fuse size. We'll put in 3 spares, and then we'll open up the unit and finish going through the rest of it. So look at that. No more high temperature at the top of those blades. The fuses look good. All is well. Clearly a significant difference by changing this disconnect switch. I'm getting ready to probe up. It's always important when you're using any kind of pressure probes that you turn them on, off the system, make sure that they're all zeroed out. Notice that negative 1.3, negative 1.5, negative 1.1. So we need to zero those out. It does that, it can do that. As the probes get older, they start to drift a lot, but then also as you change elevation. So just make sure they're all zeroed. And they are, and I have all my temperature clamps. So now I'm gonna put all the probes on real quick, and then we'll get this guy turned on. The other thing too is, let's open this guy up. Those filters are plugged. Let's see if I can get them out. Oh yeah, those things are dirty. You could barely see any light through them, barely. So we'll go ahead and take those out. We'll get those replaced today too, and we'll take them out for troubleshooting purposes. All right, I am all probed up. Everything's good. This one does have an EMS system in this thermostat. The EMS thermostat was bad, so we put this in, and the customer never replaced the EMS thermostat, so I have full control of this kitchen AC. That's kind of cool. Just looking through the electrical section, I'm not seeing anything crazy that's jumping out at me other than a rat's nest of wires, but I'm not seeing any burnt wires, anything that looks like it could have been cause of fuses blowing, which I really think it was just that disconnect. The wires look okay here. I kind of like an anti-chafe bushing here, but you know, it is what it is. They're coming up, even though it looks like they're going through bare metal. That's an actual recessed hole that's meant for wires to run through it. Don't see any issues there. Condenser fan motor wiring looks, you know, as good as it can. Zip tied together so that way it's not going to rub out. I'm not seeing anything too crazy. This right here, compressor wiring, compressor Molex plugs look good. You can see double zip ties. so that way the wires don't rub against each other because they're crossing each other. Everything looks good. Wires are home run into the contactors. I did that a long time ago. Yeah, that's pretty much it. I checked the belt. The belt is tight, no issues with that. The gas line is something to be said. Yeah, that needs to be changed. But they don't use gas heat. It's actually turned off on this because the heat exchanger is covered in dirt and grease, so we just turned it off. This unit has a newer evaporator. I think it was replaced last year because of a restriction. Newer compressors, 22 is the serial numbers. Both have R22. We had put 407C in them, but we had nothing but problems with it in the high temperatures of the summer, so we converted it back to R22. Condenser, I can see right through it. You can kind of see through it too, the light coming through, so that looks good. Yeah, so we need to put the cover back on and turn this guy on. This guy's been running for a little bit. I'm gonna run a little bit longer, maybe another 10 minutes before we really start evaluating anything, but something that I've talked about a lot. My outdoor temperature right now is about 99, 100 degrees in the shade, okay? Get into the sun, it gets higher. And we should have a 208 volt three-phase circuit being delivered to this. And we're currently at 192 volts. And as the temperature goes up, that'll drop even lower. I've seen as low as 186 volts at some of these locations being delivered. Pretty common here in Southern California, just super dense population, demand is high. Temperatures go up and we start to notice that voltage goes down delivered. So it's a bummer. Causes our equipment to run really, really hard, and you know, runs higher current that way too. All right, again, it's been running for a while. We just showed you the disconnect switch. That looks a lot better. Now we're going to test these contactors to see if we have any sort of voltage drop across them. So that's nothing on line 1, nothing on line 2. We're moving to another contactor. Nothing. Now these are just 2-pole contactors on a 3-phase system, so one leg is hot on everything. Now something that can happen, there we go, is if you don't get good connection, it'll show something. So you got to make sure you're firmly planted on the disconnect terminals. There we go. So we got no voltage drop across those contactors. Again, I showed you guys that we're delivering pretty low voltage to our equipment. 192. Across the phases, it might vary just a little bit. 192. That's pretty consistent. 192. So it's inevitable that we're going to see higher than normal current on that. All right, everything looks good in here. Now we need to go ahead and test our existing components to make sure nothing is running in an overcurrent situation. So I'm going to get the amp clamp and we're going to jump across the compressor, the indoor blower motor, and the condenser fan motor. So I'm going to go around and get all the correct RLA on each of the motors. I wrote down the condenser fan motors are allowed to run 1.42 amps, indoor blower motor 8.79 amps, and compressors 14.3. So one of the condenser fan motors is 1.32. The other one, 1.16, okay? Then let's look at one of the compressors. If I can get on there. There we go. 11.75, we're allowed to run 14.3, don't see a problem there. Indoor blower motor, let's get on that real quick. Indoor blower motor is 7.7, we're allowed to run 8.79, so I don't see a problem there. And the last compressor, it's kind of difficult to get to. Which one is it? It's black and yellow. Where are we at here? This is a little difficult. It's kind of hard to get down here. Let's just do this. I don't like pulling the panel off, but we'll be quick about it. So 12.8, and then 12.2. So we're fine. We're running under current on all of our loads, both condenser fan motors, indoor blower motor, and both compressors. So I don't see a problem there, okay? We are dropping the building temperature, but remember, it was running when I got here. I'm just coming back after someone else. So we're dropping building temperature. Let's get over and have a look at the tablet and see what the probes are doing and what's going on within the circuit. So we're looking at Measure Quick right now. We're probed up on circuit 1, first stage. Outside air temperature is about 102 degrees, so it's not too bad outside right now. Let's go ahead and scroll back. Superheat is about 3 degrees. Subcooling is about 16 degrees. Superheat's a hair on the low side, but that doesn't seem horrible to me, okay? Everything's looking good on that. Discharge line temp about 178 degrees. That seems fine, okay? So let's go ahead and scroll on over to our circuit 2, and there's a problem on this one. Circuit 2, to me, looks like we might have a restriction. So we've got 23 degrees of subcooling. So the subcooling's ever so slightly higher, especially compared to the first stage, okay? Superheat 36 degrees, saturation temperature is about 41 degrees. That's not too bad. Head pressure, not too bad, okay? Let's go on over here. Discharge line temp about 216 degrees. We're pushing right to the edge of where Copeland wants that compressor running, which is 220, where you start having potential overheat issues and oil breakdown issues. And that's all directly related to that high superheat, okay? This is a fixed orifice metering device, so it's based off of indoor and outdoor conditions. We're calling for 5 degrees of compressor superheat on this guy. We currently have 36 degrees. So yeah, we're a little bit low on that superheat, okay? I mean, a little bit high on that superheat. I'm thinking there's a slight restriction in it. I don't think it's low on gas based off of my higher than normal subcooling. Now let's go back to, or let's look at something here real quick. So looks like we're moving the right amount of air with the estimated airflow. We have about a 19 degree temperature split. Let's see, Measure Quick expects us to have about a 25 degree temperature split on this unit. So it's not always 20, okay? Next thing, let's go ahead and go back to the first stage. And let's look at the first stage. We're running about 19 degrees subcooling, okay? Again, superheat's about where it should be. Now, evaporator's clean. It did have dirty filters, right? So I pulled those out for now. We're gonna put new filters in it. But the reason why we're seeing like 19 degrees subcooling, if you look, it says typical target on this unit is gonna be about 3 degrees for the subcooling. And that is based, we are using discharge pressure. And because this is a fixed orifice metering device, you typically on these carrier units with R22, I typically see about 35 PSI of pressure drop from discharge pressure to liquid pressure. And so that's why you're gonna see a higher than normal subcooling. You think you should be around 10 degrees or something, you know. I don't know why Measure Quick is saying 3 degrees. That's a little low to me, but you know, I would typically say around, 10-ish degrees or something like that. But we see higher because of that, we're on the discharge line, okay? So when we go back to the second stage, you see we're all the way up to 20, almost 22 degrees subcooling, but our superheat's still up at 33 degrees, okay? So yeah, we've got some sort of a restriction. Now, the next thing is it a restriction in the liquid line filter dryer, okay? So if we come on over here to the probe manager and we go probes, let's look at our liquid line temp 2. That is on the outlet of the liquid line filter dryer, 104.6 degrees, okay? Then go all the way down to the bottom. I have another temperature clamp, 103.5 degrees on the inlet of that filter dryer. So we do not have a plugged up filter dryer. Looks like we have some sort of a restriction in more than likely the fixed orifice metering device, of which we already changed an evaporator a little over a year ago for that same issue. But looks like something's still floating around in the system, you know? Not really much we can do. We try to get them to change the unit. It's doing everything it can. This unit is operating as best as possible. It's gonna have a shortened lifespan with that high discharge temp on that second stage compressor, but there's not really much more that we can do about this unit. The condenser is in okay shape. It's clean, you can see through it. Condenser fan motors are moving like they should be. It's polishing a turd. This is all we can do for this unit. We're gonna tell them to keep an eye on it. I got another guy coming to bring me filters, and now I gotta go through the rest of their ACs and make sure they're all working properly too. The other thing, they are complaining about high temperatures in the kitchen. I need to get to this makeup air unit because it has an evaporative cooling section. We gotta make sure that the water pump and the filters are clean and the cell deck media is clean, because that affects, and those filters are plugged. So that affects the cooling for the kitchen too. At least it tempers the air because it runs a water pump and evaporates the water as it's running through there. So that's it on this one. we will give the customer the keys and tell them to keep an eye on it. So this is actually a really common failure as far as the disconnect goes on these units. After a couple years, these disconnects really start to degrade, especially when these customers aren't doing routine maintenance. They're not having us go around looking at terminals, seeing if they're starting to get discolored. It kind of just, you get a call and it's like, well, in my opinion, they're beyond repair. Now, I realize there's some people out there that, may make it work and they can get by for a little while, but I'm more of I don't really want to spend a bunch of time trying something. I'd rather just put in a new disconnect and be done with it for another couple years and then move on to, deal with it later. I really don't want to have to be the back and forth of trying to sand something, seeing if it'll work. And again, to each their own. If that's how you operate, then so be it. That's fine. I'm not judging you. It is what it is. These videos are the inner workings of my brain. This is how my brain operates, and I'm not always right. 100% I will admit that, okay? So I always make mistakes. But went through this unit, diagnosed a bad disconnect switch, changed that. Really important, leave spare fuses for the next guy if the customer allows you. I don't really give the customer a choice. That's part of my price. Spare fuses in there, okay? That way, the next time you got fuses, you're good to go, okay? And just try to do your best. Again, this is not a perfect install. I'm sure there's people out there that are going to leave comments that the wiring in this is just a disaster, and it is. This is just this type of equipment. This is how it is, and I can only do so much. I'm not going to spend weeks there trying to reconnect or to zip tie all the wires and make them look absolutely perfect, trim them up, run them in different routing positions. The customer doesn't want to pay for that, okay? I do the best with the time that they allow me. Now, once we changed the disconnect switch, then we had to move on to the rest of the unit. Clearly, the first thing, make sure the unit is clean. Make sure the belts are tight, filters are clean, condensers clean. There's no sense in spending hours trying to diagnose a problem and finding out that it's got a dirty coil or something like that. So do your best to find that stuff when you get there. I went through it. I looked. Clearly, the filters were plugged, pulled them out. We went ahead and replaced that as part of this. I went and changed filters actually in every unit on the roof, and then made sure the evaporators and condensers were all clean, made sure the drain lines were clear. Again, it sucks that these customers aren't doing routine maintenance, but at the same time, I don't have time to go back tomorrow for a silly drain or something like that. So I'm on the roof. I just went ahead and took care of it, got it knocked out, right? So went through the unit, probed up on it. Really important that you let the system operate for a significant amount of time before you start diagnosing anything, okay? And then I started to notice, the high subcooling on the second stage, the high superheat on the second stage, and that's leading me down the path of a restriction in the system. Now, I don't think there's a restriction in the condenser. It's always possible, right? I think the restriction is going to be in that fixed orifice metering device. That's a very common place on these units. But before I start jumping down that rabbit hole, I had to check to see if the liquid line filter dryer was restricted, okay? And it was not. Made sure we did a temperature clamp on each side of it. If I start to see anything more than 3 to 4 degrees of temperature drop across that dryer, I start to suspect it. That's not where we were at. Everything seems fine with that. So there's some sort of a restriction somewhere. I think it's in the metering device, which is very, very common on these guys. Now, this system has a lot, or this unit has a lot of new compressors, new evaporator. There's been a lot of work done to it, but I tried to get the customer to change the unit. Like, it's sometimes really painstaking, when you're like, really, I do not suggest these repairs, but a lot of times they just look at a flat amount. They see how much is it to change the unit, how much is it to repair it. And this doesn't make sense to a lot of us, and it's their money to spend. So, it is what it is. But to them, I'm like, hey, let's look at the repairs we've done in the last 10 years on this equipment. You can buy this equipment 3 times over for the amount of repairs that I've done. But for whatever reason, they don't always see it that way. And I'm sure there's reasons on their side, corporate budgets and different things like that. Who am I to say, they're wrong? I'm just there giving them facts. It costs this much to repair it. It costs this much to replace it. What do you want to do? They say repair it. Okie dokie. I'm going to go about it. But I always warn them, I don't suggest these repairs. This unit's really, really beat down, and they still choose repairs, so it is what it is. So this guy, in my opinion, has a plugged up metering device on the second stage,
and it's causing that high compressor superheat, which is leading to issues, okay? Because eventually it's going to break down the oil in that compressor. It's going to start to damage the insides of the compressor. It's not going to make it through too many summers like this, but it's functioning and it's operating. They want to leave it that way for the time being. I already gave them the information and they said, yeah, it's working, it's operating. Let's just see what happens. Okay, you know, I can only do what they want me to do. So I did my best on this. Now, I mentioned that I went through the rest of the roof. I changed all the filters, and I actually did find a bad water pump on that makeup air unit. Changed the water pump, cleaned up the distribution lines on the water delivery system going above the cell deck media. I didn't get video footage of that, but their kitchen is going to be significantly better. I also went through all the rest of their ACs on the roof, found that one of them had a stuck outside air damper. Of all things, a tech screw, a 5/16 tech screw, and I didn't get footage of this, unfortunately, but a 5/16 tech screw literally fell down into the gears of the economizer damper. I wish I would have got footage of this. And it just wouldn't let the economizer shut. So it was just bringing in a bunch of outside air. I turned the system off, unplugged the economizer, pulled out that 5/16 tech screw, the economizer springs shut. I turned it back on, it opened and closes, and this was on another AC. It works fine now. So they're going to notice a huge difference in their dining room. Customer's happy, and that's it. I really appreciate you making it to the end of the video. Thanks for coming along on these videos. It's very interesting, you know, and I say this all the time, but it's still, you know, I'm starting to understand it a little bit more. I'm starting to be used to the fact that people want to just watch these things, but it is kind of crazy to think that you guys just want to watch me work. I mean, that's essentially what you're doing. I guess there may be some sort of educational value in some of what I do. Maybe it's just, let's not do this because he's an idiot. Maybe that's in there. I don't know. But thank you so very much. I really do appreciate you. Remember to be kind to one another. You really don't know what the next guy's going through. You don't know, you know, I'm not justifying anybody being a jerk to you, but just, you know, sometimes it's easier just to be kind to someone else instead of just being a jerk to them. So just remember that, okay? Again, thank you so very much. If you haven't already, please consider subscribing to the channel and checking out my website, hvacrvideos.com. We have merchandise available, hats, and all kinds of different stuff. It's a great way to help support the channel. There's a bunch of links in the show notes of this videos on other ways that you can support the channel via PayPal, Patreon, YouTube channel memberships. Also, TrueTechTools.com. If you're interested in purchasing any tools, you can use my offer code, Big Picture, on most of the items on their website. That'll get you an 8% discount, and I get a small commission when you do that. So it's a great way to help support the channel. Okay, thank you so very much, and we will catch you on the next one.